Starting on page 12. Okay, so then what is the coordinate for letter A? Raise your hand, participate. All right, Jordan Deeger, what do you got for A?
I got 4.
4-1 is good. What about letter B? Gus. Excellent. Letter C, Ryan. Be careful, X first. So look, if I'm here, here's my C. I have to go to 6 first, and then I don't go up or down. So it's 6, 0. Letter D, Johnny G. 1, 4. Sounds good. Ready for some follow-up for tickets? You ready? What points lie in quadrant 1? Kelsey. Say it again, hon. I didn't hear you. D and A is good. Come and get a ticket for that. What point lies in... I tell you, I'll do this in reverse. Point B is in what quadrant? Caitlin. What quadrant is that in? No, not 3. Samantha. That would be 4, because you got to kind of visualize. This is my 1. 2 would be here, even though it's not pictured. 3 is always at lower left, and so this is now 4, and here's my B. Come up and get Sam. What point is not in any quadrant? Amanda. Correct. And what do we call that? What axis is that? Look up here because it'll tell you. What axis is C on?
Oh.
You got it. Come on up. Okay, so that's that page. These were tricky. You had to kind of recall your information on greatest common factor. So I'm curious, what did you get for 2A as being, and I'll give you a hint, I will tell you that there's only 2 coordinates, 2 points that satisfy this criteria of a GCF of 3. All right, girls, you get them both right, I'm going to give you a ticket because this is tricky. See, 0 does not have a GCF of 3. The only common factor for 0 would be 0. So it's not, we can't include that one. Well, now we know that's out of the picture. All right, Chris, you got, okay, where? How many have 6 and 30? Guess what? No good. You know why? Has a common factor of 3, but the greatest common factor is 6. 6 goes into 6, 6 goes into 30. Can't use it. We need to find a GCF of 3. No higher, no lower. Caitlin, guess what? You got one of them. There's one more. Can you get it, Caitlin? Because if you get it, I'll give it to you. Guess what? What goes into 6? It's the highest number that goes into 6. What's the GCF of 6 and 18? Let's do it that way. 6 is the GCF of 6 and 18. 6 goes into 6. 6 goes into 18, so we can't use it. Let's do it this way. What about 4 and 20? Cross it out. GCF of 4 and 20 happens to be 4. No good. What about 8, 4? What's the GCF of 8 and 4? I'll give you a ticket for that. Correct. Come up and get. That's not 3. What about 2 and 3? Well, you can't really do it because 2 is prime and 3 is prime. No good. I will tell you it's one of those 2 remaining numbers. And we already have one of them, so we got this already. So obviously, what's the last one? Lauren, 15 and 3. Tricky question. Makes you think, and you also have to recall previous information. Okay, ready? So we can see these numbers again, because we need to see them. This one actually I think is a little bit easier. What are the ordered pairs whose second coordinate is a prime number? Have to get all of them to get the ticket. All right, Jordan Yang, go. That's a winner. The second number has to be prime. 3 is prime, 3 is prime, 5 is prime, and 3 is prime, so it works. None of the others will work. Look, 20 is not prime, 10 times 2 or 5 times 4. Obviously 4 won't work, 2 times 2. 15 is a product of 5 and 3. Can't do 30, 10 times 3, 6 times 5. Can't do 18 because that's 6 times 3. All right? So that's those automatically out of contention, and that leaves just the ones that Jordan said. All right, number 3. All they want you to do is tell the quadrant that it's in. Lo, go. Rattle them off. What do you got for -2, 5? Use the Roman numerals, okay? Get used to how it's done. So if you wrote the number 2 out, do it as a Roman numeral. Keep going, bud. But listen, see, now look at, a lot of people have questions about this. Look, I realize that 9 is nowhere on your coordinate plane, but it's trying to get you to think. Because they're not asking you to plot the point. They're just asking you what quadrant would it be in. So what do you think, Log? Right, because look, here's 9 point, here's this would be over here, this would be 8. So here's 9, 9.2, I'm kind of visualizing it. And then I got to go up 7. So I know anything in this area here has to be quadrant 1. Keep going, Log. Good, no quadrant y-axis. Let's see, what, 8, -4? 8, -4. Right, that is quadrant 4. -1, -8. You got it. Any questions on that? I want you guys to be like totally familiar with your quadrants and plotting points. That's got to be like routine for you in order for us to go on to what's going to be lesson 16 tomorrow. Number 4 is a really, really interesting question. And I will even tell you that I got it wrong the first time I read it. Jackie claims that points with the same x and y coordinates must lie in quadrant 1 or quadrant 3. Do you agree or disagree? Can I just say, who agreed? Who disagreed? Who wasn't sure what to do? All right, here, I'll give you an example. The same x and y coordinates. Give me a number. 6. We're going to make the x 6, the y 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What quadrant am I in? What quadrant am I in? That you got to know. Call it out. 1. So far, am I in 1 or 3? Give me another integer. Give me a negative integer. Negative 3, we're going to make the x and the y the same. Neg 3, neg 3. 1, 2, 3. 1, 2, 3. What quadrant am I in? Sam?
3.
So far, I'm in 1 or 3. Give me another number. Give me a number. Any number. Call out a number. 1 to 10. 2. x2, y2. Go out and go up and plot it. x2, y2. Start from 0. Ready? Positive or negative 2?
Positive.
Left or right?
Negative.
We said 2, 2, right? Positive 2, positive 2. Left or right?
Left.
1, 2. Ready? My y is 2. Up or down?
Up.
Plot it. What quadrant are we in?
1.
So far, so good. Give me a negative integer.
7.
Go plot it. Negative 7, negative 7. And then you got to go down your negative 7 too. Plot it. What quadrant are you in?
Quadrant 3.
So, here's my point. She says that it has to be in quadrant 1 or quadrant 3. Is she right? How many say yes? Guess what? There's one exception. Can you think of it? It's a great question. Give me the exception to the rule. Lauren. 0, 0. 0, 0. 0 is an integer. They're both the same. Doesn't line any quadrant. So therefore, technically, you have to disagree. By the way, Lauren, come up and get a ticket for that one. Disagree, and the only exception is 0, 0. I mean, she is right most of the time. That's the only point that would not work. Even, guys, give me a fraction, a half, 0.5, 0.5. Still going to be in quadrant 1 or quadrant 3. It has to be 0, 0. It's the only set of coordinates from greater than 0 or less than 0 to infinity that will lie in quadrant 1 or quadrant 3. It's the only exception out of millions and millions of possibilities. Okay, they want you to locate and label the set of points on the coordinate plane. So let me erase this. And we'll do it right now. Starting at 0, we've got negative 2, 1, 2, pos 5, 1, 2, 3, 4, 5. Negative 2, pos 5. Looks good? Neg 2, pos 2. 1, 2, 1, 2. It's right there. Neg 2, pos 7. It's going to be tight, but there it is. Neg 2, neg 3. Right there. Negative 2, positive 8. Real tight, but it's in there. And those are my 5 points. Okay? Is there any follow-up questions to that? All right, number 6. Another great question. It's another one where it gets you thinking a little bit. You have to pick any 5 points on the coordinate plane. The criteria being they have to have an x-coordinate of 6. So I don't know if it helps you before you plot it. Give me 5 points whose first coordinate is 6. Just give me something. Let's do it. Okay. Look, guys, the first coordinate has to be 6. Give me another. Go ahead, Amanda. The first coordinate has to be positive 6. So you could do 6, negative 4. You want to do it? All right. Let's do another one. Mikey, first coordinate has to be 6. Give me a set of coordinates. Two more we need. Fritch, give me one. And just for the heck of it, give me one where the second coordinate is something other than a whole integer. Give me a rational number that's not a whole number. Just for fun. 6 and what? 6 and 0.5. Okay. We can do it. All right, so now we're going to plot it. 1, 2, 3, 4, 5, and 6. First one is 6, positive 3. 1, 2, 3. There's a point. I'll label it. And that's done. 6, negative 4. I know where I've got to go here. I'm along the axis. And my x has to be 6, but now I've got to go down 4. And I realize yours might be different. But the concept, no matter what you plotted, these answers will all be the same for all of you. It should be. Okay, done. 6, positive 4. Very close to its neighbor, 6, 3. And we got another one here, very close, and that's my 6, 5. They're all bosom buddies, hanging out. And ready? 6, negative a half. Well, here's negative 1, so a negative a half has to be here. Oh, you said positive half, didn't you? Okay, I'll erase that. Same idea, but I'm going to go up a half. And that is 6. And you know what? I'll call it a half so the decimal doesn't look like a negative symbol. 6/2. Okay. No matter what points you plotted, these answers at the top will be the same. What is true of the y coordinates below, and we only have one, below the x-axis? What's true about every single number, every single y coordinate below the x-axis? What? Positive or negative? They'll always be negative. What's true about the y coordinate above the x-axis? Coordinate. All positive. And then finally, what has to be true of the y coordinate on the x-axis? Which we don't have, but I'll put it in here. Here's a point on the x-axis. What is true about the y coordinate? Come on, think. Ryan, it's got to be 0. Okay. And that's that. Okay, what I want you guys to do, because I think you're ready for it now, this here, this page 6, or this page 15, question 6, kind of hopefully get you now thinking, where you can go back and do pages 6 and 7. Because I was a little worried about that yesterday. I didn't know if you can handle it yet, but now I think you can. So you're going to go back and do 6 and 7, and that will really essentially complete everything in book 14. Okay? So group up, do 6 and 7, and then if you get done, you can actually start your exit ticket.